Good morning. I would like to explain a statistical parody or an analytical parody. What it has been observed most often is that a very infamous sentence, a drawback of the subject which has been extrapolated to explain almost every shortcoming of the subject. So what I try to hint is the often used example that correlation does not imply causation. What is this drawback? Let's try to understand it over here. So if you try to look at the drawback and prepare it from 100 different peoples and list out what are the top 10 drawbacks of the subject. So what you'll get is obviously first that correlation does not imply causation. You ask them what is the second most drawback or from your surveyed, and then the second most drawback of the subject is that causation is not implied by correlation. And the third one, so it will be something like this: thunder the critic in Greek, correlation does not imply causation. What exactly is it then? What we are trying to understand over here, I will try to explain it through a very simple example. That is maximum temperature on 1st of the months January to December and the number of letters of the Prime Minister of that country. So first Prime Minister, number of letters, and January 1st maximum temperature. Second Prime Minister, the number of letters in his name, and the temperature, maximum temperature on 1st of February, so forth. So here obviously it is very plain that why should the number of letters in the Prime Minister's name have got anything to do with the maximum temperature. Clearly it is very simple that correlation among this data will not imply causation. Such a phenomenon is also called as spurious correlation. What are we then supposed to do? Right? We have to make the prediction of the maximum temperature of, let us say, the November month based on 10 months data. So what we can rather do is take the humidity on the last day of previous month. So you are talking about humidity on December 31st of the previous year and try to relate it with the maximum temperature on 1st of January. Similarly, 31st January humidity will be taken as the input for 1st January's maximum temperature. Let's try to look at a small hypothetically created data set. So for some particular country or a hypothetical country or maybe the hypothetical prime ministers. So here you can see that the number of letters is almost directly proportional to the maximum temperature of the first day of month, which we know as a phenomenon of spurious correlation. Humidity on the last date as well is, it increases, the max temperature also increase, which makes sensible. So where do we go now from here? An obvious thing here is, if you remove the number of letters, if you drop this column and only consider the first and the third column, you should be done. But what happens if you merely change the labels? In this case, will the same data which was there in the case of Prime Minister, is that useful? Or what was earlier here as the humidity, if the variable name is changed, is it, which is correct now, right? So by changing the labels. So what does all this mean? Don't try to extrapolate the limitation of a correlation. That is what it means. So correlation, to conclude, to sum it up, correlation as a measurement is useful and it measures between the numbers and not the variable names. Statistics cannot help you if you don't know your own variables. But spurious correlation is a beaten to death example. A bit of common sense is all it takes to avoid it. And what has been observed is that most often whenever you don't understand, okay, put it under the carpet saying that correlation doesn't imply causation, so it's not useful for me. But that is not how you should be looking at it. You should be judicious in your choice of variables, trying to explain the output or the regressant, and accordingly if the numbers tally up and they say that yes, the correlation is significant, you should accept it. If it says it is not significant, it is insignificant, you should reject the variable. That is how it is supposed to be. One final point. We all know the chemical formula: 2 hydrogen and 1 oxygen gives us water. Does that mean we can understand any kind of a complex chemical equation? Answer is simple, no. Why? Because there is only so much you can do by extrapolating. Similarly, every time correlation is found to explain it, don't say that I knew, I'm not surprised. On the other hand, if correlation is insignificant, don't trash out the variables as saying that the model is not appropriate. Thank you.